Hello and welcome to our webcast today on Automate ZOS STIG Compliance with Real-Time Continuous Security Monitoring and Auditing. My name is Yvonne Wheaton and I'll be your moderator today. I represent Software Diversified Services. Here's what your dashboard looks like. You're probably used to that by now. You'll find handouts for the presentation in the handout section, and you can send us a question at any time in the question box. We will be answering those questions at the very end of this webinar. And when you leave, there'll be a brief survey presented to you. So if you could take a minute and fill that out, that would be helpful. Thank you. Founded in 1982, STS is a Minnesota-based company that has a 35-year history of offering security, encryption, data compression, and network monitoring customer-centric IT infrastructure solutions. SDS has licensed over 1,000 enterprise clients worldwide, including many Global 500 companies. SDS supports over 25 ZOS, MVS, VSE, and VM mainframe and distributed systems business software solutions. We are an IBM partner in development and an advanced member of IBM Partner World, and SDS was named to the Cybersecurity 500 list of the world's hottest and most innovative cybersecurity companies for the second quarter of 2017. And you can stay connected with us with our latest news, technical information on LinkedIn, Facebook, Twitter, and our blog. Okay, so here's our agenda for the next 50 minutes or so. Stu Henderson, a founder of the Henderson Group, which provides computer security consulting and training in a variety of technical areas. Mr. Henderson is an experienced consultant, one of the foremost ZOS security experts today. He specializes in effective computer security for IBM mainframes, Unix, and Windows. Stu Henderson will be discussing how to know what's going on with your mainframe. Itzhak Mutzak, founder and managing director of SecuriTeam Software, creator of several conversion products, as well as the company's flagship product, IronSphere IT-GRC platform. Itzhak will be presenting IronSphere Mainframe Continuous Security Monitoring, along with a demo of the products. Following Stu and Itzhak, like I said, we'll have the Q&A session, so go ahead and put the questions in the question box. It's my pleasure to hand the presentation now over to Stu Henderson. Stu?
Thanks, everyone. Today I'd like to talk about a problem that's facing almost everyone with a mainframe. That is the difficulty of understanding exactly what's happening under the covers. So we're going to talk a little bit about what some of the reasons are for this and what we can do about it. And here's our agenda. We'll start out with an introduction and history. We'll tell you some things that you may know, but if you don't, you want to know them because your auditors do, and you'll actually find them useful. And we'll wrap this up with a summary and a call to action. But here's some history. A very long time ago, IBM mainframe computers used punched cards. The security was basically, they were in a locked room. And in the beginning, they only ran literally one program at a time. And with a little bit of effort, IBM improved it. You could run 3 or 4 programs at a time. We didn't know what was going on under the covers, and frankly, we didn't care because the thing ran smoothly and there wasn't anything complicated enough in the output to give us concern. But of course, life always gets more complicated. So we added terminals, and we all started having not just 1 or 2 online users, but hundreds and eventually thousands. We also ended up running literally thousands of programs at the same time. And then, just to add spice to it, we connected it to the internet. And Lord knows how many people are talking to it or able to talk to it. Now, to try to sort this out, we added a log file called SMF. Now, what the log file does is it tells us what happened in the past, not necessarily what's happening at the moment or in the future, but just what happened in the past. So we tried to take the SMF data, and we had lots of programs to sort it and print it and chart it and graph it and do exception reporting. We also had, back in those days, a stable, sometimes a dozen or more, technically knowledgeable, very highly trained system programmers who'd been doing the job for decades, who understood the internals of MVS, of JES, of DB2, of VTAM, and they also knew the history of how things had developed, and they had a lot of organizational knowledge. They knew why things were set up the way they were because 10 years ago somebody made a decision or there was some complication. So the knowledge they had in their heads was incredible. It was both technical and knowledgeable. We also had some additional tools. We had hardware monitors. They were like great big voltmeters or collections of voltmeters with logic boards that would do ands and ors. And we had software monitoring tools. These would let us know what was happening in real time. So if response time was bad, we'd have an idea of what was causing it. Well, we used the SMF data for a large number of management controls. And it wasn't just security and audit. We used it for capacity planning. We used it to manage response time and make sure the response time we were delivering was within norms or what people would find acceptable. We used it for problem management. We said every time a production program blows up, every time there's a problem with the system, or the hardware, the software, the air conditioning, or the electric, we'd use the SMF data to help us manage those problems and minimize them and respond to them. We also use this, the really sharp shops use this for cost analysis and chargeback, and of course, security and audit. Now, the SMF reports were always a day late, never a dollar short, but always a day late. And sometimes they were so voluminous, a typical mainframe nowadays will have over 1 million SMF records every day. So sometimes the volume of output from the SMF reports was so big that no one would bother reading them, or if they were forced to read them, they'd glaze over pretty rapidly, and sometimes nobody really understood what they meant. Well, let's make things more complicated. We'll add the security software. And now our mainframe technical staff with all that knowledge starts retiring. And just to make things more complicated, IBM adds more technical issues and products. We've got MQ series for message queuing. We've got Policy Agent. It's a firewall for TCP/IP. Who could have imagined this? We've got DDF for users talking over TCP/IP to DB2. And then this blows the distributed people away. We've got Java talking to CICS. Well, it's gotten more complicated than some time ago. It got more complicated than I think any one person could get his arms around. And while this was happening, the computers got bigger and faster, more complicated. We partitioned them into LPARs. We combined them into sysplexes. And there's an awful lot going on, and nobody really had a picture in his mind. Well, it wasn't just that things got more complicated. Then the auditors started coming by, and they very often knew even less than we did about what was going on under the covers. And so their solution was very often to use checklists. And sometimes their checklists were based on Windows. Now, mainframe passwords have always been a maximum of 8 characters. There's about a zillion places in the mainframe where passwords are stored, and they have a maximum length of 8. IBM actually looked at it and thought about trying to make it longer than 8 and concluded it was not possible. That's why we have password phrases. There was some weird glitch in the encryption algorithm in Windows. The algorithm that Windows used to encrypt passwords, for some reason, if the passwords were less than 14 characters long, they were easier to hack in Windows. Well, that was the only checklist some auditors had, and so they try to apply this to the mainframe, and well, now we have password phrases. Thank goodness. Well, I'm being sarcastic. So while this is going on, our tech staff had all this knowledge in their heads, and they kept on retiring, and things got more and more complicated. And just to ice the cake, we heard about a European data center, and actually there are many more examples, but there's one in Sweden that was best known, the Logica hack. It was a mainframe data center. They had MVS with RACF, but it could have been ACF2 or top secret. it got hacked over the internet. We'll give you some details on that later. And it turned out the hackers had been inside, had broken in months earlier before management was even aware that they were being hacked. Well, with the auditors coming by with their reports and turning the reports into senior management and everybody reading headlines about breaches and nobody wanting the company to be embarrassed, we started getting questions from the auditors and also the C-suite. Do we have any security problems, or have we had any breaches? Of course, we'd always reply no. And sometimes someone would add that we know of, because of course, if we had one that we didn't know about, and with all the complications, who knew whether we had complete understanding of any breaches? Well, there you go. So to wrap up the introduction, we need to develop our own security standards. We can't rely on the ones that the auditors bring to us, and we need to convince the auditors to use them. And frankly, that's fairly easy to do. If you develop a decent standard, of course, it takes some technical knowledge to do this, but if you develop your own technical standard and standard for security settings, for example, and you tell your auditors, this is the standard we use in this shop, they're more likely to, in fact, if you press hard, they will use that to audit you if it's a reasonable standard and you hold them to it. They will have to use that to audit you against. But we need help in addressing all these technical issues. And we also need better data collection and reporting, because the SMF data, the volumes of SMF data, while it's very useful, it isn't enough, it isn't real time. And we don't know by ourselves enough to put the SMF data together to understand what's going on, especially since our technical staff is getting thinner every week. So now I want to talk a little bit about some things that managers know and auditors know, because a lot of what auditors are asking us to do is basic management controls. So the first thing we want to point out is was first said by Peter Drucker, the management consulting guru. He said, you can't manage something if you don't measure it. And that makes perfect sense. Now, this applies not just to security and auditing, it applies to all of the management controls, capacity planning, problem management, response time reporting. It doesn't do us any good to report a response time is 3 seconds on average if we don't have a standard, maybe a contract with our end users to report against. And actually, what a lot of shops do is when they think about developing the standard, and I'm describing this as an example of why standards can become more sophisticated and therefore more useful. Sometimes you have that weird 1% of the time, or 1% of 1% of the time, that the response time goes bluey and it's 4 seconds when normally it's 1 or 2 seconds. So you can rephrase the standard and get your users to agree to it. It's a reasonable thing to do. Example, something along the lines of, our mean response time will be 1.5 seconds, and it will never be more than 5 seconds, which gives you a little bit of flexibility for that odd instance that happens so rarely that no one has any real business complaining about it. Measurement is meaningless if you don't compare it to a standard. So you want to have a way of measuring. You want to have a standard to compare the measurements against, and you need to actually do the measurement. And the sooner you do the measurement, if you wait till the next day to do it, well, you'll be a little bit late in some of your management decisions. So the things you can compare, the things you can use as standards, you can have a regulation, you can develop your own standard of how things are supposed to be set, or some other arrangement. But for each thing you want to accomplish, you want to know what your standard is and how you're comparing against it. And sometimes you'll have no choice, it will be a regulation. Sometimes it will be your own standard, and if you don't provide your own standard, sometimes auditors will apply their standards, which sometimes may not fit well. So if you ask an auditor, a knowledgeable auditor, what is auditing? he's going to give you an answer something like, it's the evaluation of the adequacy of controls. And you ask a knowledgeable auditor, oh, what's a control? He says it's comparison to a standard. So really what auditors are supposed to be doing when they audit is they're looking at the controls you've implemented, the measurement, the standards, and the comparison of the measurement to the standards. That's what makes the control. And you could add a phrase on the end of it, for some specified purpose, such as managing response time or ensuring our security is under control. But if you don't have your own standard, as we said before, auditors are likely to use their own checklists. If you don't have your own standards, you're going to live with the ones the auditors provide for you. And some auditors will are actually going to say they're starting to do this more. Instead of just having a checklist, they start out by saying, do you have a standard? Do you have a policy? Do you have the basic management control documents that would be necessary? Because if we do our checklist and you happen to be good this day, but you don't have the policy and standards and procedures and baseline documents for you to be able to keep things under control, then maybe that's not good. So a lot of auditors are starting to say, if you don't have the standards, if you don't have the baselines, if you don't have the policy and procedures for measurement, for development of a standard, and for comparison against the standard and acting on that comparison, they'll treat that as an audit finding. The baselines, I should explain what we mean by baseline. A baseline is a document that says how your settings should be. So for example, if your security software is RACF or ACF2 or top secret, you've probably got features you can set like minimum password length or what characters are allowed, or whether you use, RACF calls it erase on scratch, the other two call it auto erase, or what sort of encryption you use for passwords. All of these are options that can be set in the security software. And the auditors will look at how you have them set. If you have a baseline document is something that says for your shop, approved by your management, this is the way we set the options in RACF, ACF2, or top secret. This is the minimum password length. This is the encryption we use for passwords and so on. That's a baseline document because it sets the standard for your configuration options. And if you don't have the baseline document, you don't have a standard for how all the things in your configuration files. Now, when I talk about configuration files, we've got configuration settings for the security software. The PARM labs are the configuration files for MVS itself. But you'll find that CICS has a configuration file called the SIT. DB2 has a configuration file called DSN-ZPARM. TCP/IP and USS and Policy Agent and FTP, your change control software, your job scheduling software, your tape management software, all of these have configuration files and would be useful to you, not just to deal with the auditors, but also for dealing with the world at large, for you to have baseline documents. One of the reasons you want them is to say, if somehow the setting gets misset, either deliberately or accidentally, someone changes a setting to something that it's not supposed to be, and maybe that system programmer just retired last week, how do you know what to reset it to? Well, the baseline gives you that information. Plus, it lets you say to the auditor, this is the standard we use here. This is what you audit us against. And if you want, go evaluate the standard for reasonableness, but otherwise, this is the standard we're using. So baselines basically say, these are the options that we set in our configuration files right here. Now, if you want to develop your own standards, we've got several starting points from the federal government. We'll give you details, but you've probably heard of the STIGs. There are some other documents from NIST, the National Institute of, I think it's Science and Technology. It used to be standards of it. I think it's Science and Technology now. NIST is the federal government agency that does standards for us. And they've given us the starting point for many of the configuration files, the baseline documents. If you have your own standard, auditors can audit you against that instead of against their own checklist. And of course, any preventive and corrective controls are going to be better than detective controls. So our lives are going to be simpler if we can find ways to start developing and formalizing our own standards, including baselines. And these government documents will give you a good starting point, and the technical knowledge of whatever system programmers you still have on staff will help you also. So you can take advantage of the work the government has done to get us started. Our lives are going to be simpler if we find automated but flexible ways to compare against our own standards. We don't want to do our own ad hoc development of programs to measure or massage SMF data. It's not fast enough. We need something automated and flexible. And we also need real-time exception reporting and trend analysis. You don't want to read reams of violation reports. Nobody will pay attention to them. You want exception reporting, you want trend analysis, you want comparison against limits. You'd like to get a report almost every day that says everything's within standard. So that wraps us up. We're going to give you a little more information, but I'd like to thank you all. And here's our information source. Thanks very much.
Thank you, Stu, for that informative presentation, which will lead very nicely into the next section of our presentation by Itzhak Mitzak. I'd like to hand the presentation now over to him. Itzhak?
Thanks, Yvonne. The mainframe is more than 50 years young. Since its first version in the 60s, the mainframe has dramatically changed. It supports clustering, called sysplex, modern languages like Java and Perl, new data formats like XML and JSON. The old SNA protocol has almost deprecated by TCP/IP. Lots of the Apache Foundation solutions like Spark, Tomcat, and Apache Web Server are running on the mainframe legacy operating systems. The mainframe has a presence in the cloud. Some people may say mainframe is the cloud. So the mainframe is a modern computing environment, but at the same time, the mainframe industry suffers a staffing disaster. More than half of the mainframe experts are over 50. People who retire as no one to transfer knowledge to, and the gap is even more dramatic in the area of mainframe security. We perform penetration testing and security assessments for almost 40 years, and in the last few years, it's hard to find a mainframe security expert within the client security department. In order to preserve the knowledge, we created IronSphere using modern technologies which most people are familiar with. I'll start with a short concept and facilities presentation telling what we do and how we do that. And afterwards, I will demo the IronSphere user interface. This presentation tells the story behind the product, from the need for a new security assessment paradigm, which technologies and frameworks used, and how we use them. IronSphere is an IT GRC kind of product. GRC stands for governance, risk, and compliance. Basically, IronSphere is a tool to perform automated readiness reviews. You may already have heard about SIEM and even use one. So let me first tell you what GRC is and how different it is compared to SIEM. SIEM stands for Information Security and Event Management. And as the name implies, it's an event monitoring tool that aims to identify illegal activity based on events recorded in logs collected from your systems. It's SMF in the case of the mainframe. GRC is based on findings collected from security assessments. A finding is a result of an actual security control setting compared to a required value. SIEM tries to validate the event based on a 7W model. Who did, what, where, when, etc. GRC is based on a hardening framework, or what we call best practice, which dictates the correct values and setting for the security controls. The tools are also different in terms of life cycle. SIEM is a real-time monitoring tool and requires making decisions in real time or close real time in order to block an internal or external attack. GRC systems cannot automatically just change the security settings value because it may impact availability, stability, or any other metrics of your system. It is also hard to precise with SIEM as they depend on your own rules, and the rules are continuously changing. So SIEM systems usually generates a lot of false positive alarms. Last thing to remember, SIEM is based on rules you created and need to be refined and maintained as the systems and staff may continuously changing. While GRC is based on a standard and change according to your software mix and lifecycle security control settings. IronSphere is based on well-known federal standards. First of all is that these are STIG on the right side of the screen. STIG frameworks is basically a best practice document or hardening framework. There are other hardening frameworks like CIS benchmarks. However, STIG is the only one that supports mainframes. The STIG documents set the standard for system and third-party products configuration best practice. ICM on the left side is less famous, but very important concept. It was created by the National Institute of Standards and Technology when they recognized in the early 2000s that the then standard of 3 years assessment cycle is irrelevant to the dynamically changing technology. The idea behind the ICM is to monitor the security controls 24/7, resulting in a clear and accurate view of the system. Face of those products run in a mainframe, and somebody needs to generate and review the reports system after system. It's a time-consuming process. The result is that there is a time gap between the collection phase and the reporting phase, assuming somebody really has the resources to generate and review the reports. Most clients we have seen don't have the resources nor the knowledge. IronSphere approach is different. It's only collect what is relevant to the diagnostic when it runs. So the diagnostic routines dynamically discovers the assets it monitors. For example, a CSS diagnostic routine will discover all active CSS regions. It then collects security control settings, for example, the CSS SIT parameters, and compares them to the required setting. we only report finding. We don't want to confuse the person who is watching the results. The server validates the origin of the message using a certificate that the agent presents, stores the results in the database, and allows authorized users to view the results using a web interface. So why ICM is so important? The reason is that manual assessments are expensive, take long to complete, and usually executed in annual cycle. The fact is that at only short window of time, the system is assessed, recovered, and in compliance with the hardening requirement. As the rest of the time, it is compromised because while assessments are snapshots in a long cycle, systems are continuously changed according to business requirement, staffing issues, etc. In order to supply a real-time, up-to-date visibility into the system's security status, IronSphere uses the concept of baselines and updates. Baselines are created in cycles. The default is 12 hours. It takes up to 3 minutes elapsed time to run the entire diagnostic routines. You can decide the interval yourself based on the resources, industry risk, and other criteria. Using system exits, the security controls are monitored, and when a change is detected by an exit, it will trigger the related diagnostic routines, which then reports to the IronSphere server. The result is an up-to-date view of the security status of your system because the baseline is updated. This view, the up-to-date view, is a collection of all last executed diagnostic routines. The outcome is not only up-to-date report, but also a calculated risk score for the monitoring systems. Aimed to serve the non-mainframe security expert, IronSphere designed with simplicity first. No mainframe knowledge is required, no mainframe access. You don't have to log on to TSO or any other user interface of the mainframe. Once installed and configured, IronSphere agent will run unattended from IPL, which is not needed for starting the product, to shut down. The result are not left anywhere on the mainframe, so nobody can see your risks, but securely sent to the server, so they are visible only to those who are authorized to access the IronSphere server. IronSphere implements the STIG security ranking system, which is only 3 severity levels: low, medium, and high. No green skins, no human involvement at all. We use a web interface and preserve the entire STIG text, which are self-explained, so it's easy to understand what the risk is, who is responsible to fix it, and how. The combination of the STIG text and the result table makes it easy to understand the details. The overall scores of the monitoring systems shows the big pictures, while the reports show the details. We use dashboard concept to show the big picture by the calculated risk levels measured on all running agents. They are organized by operating systems, showing the highest risk level currently reported by the agent. Moving from the main view to system view by clicking on the system gauge displays the agent list of this operating system, and another click on the agent icon will display the detailed report of a single system view. STIG has the concept of predefined security level. If at least one of the security controls that are monitored by the STIG or the check is not set properly, it's a finding. The predefined severity is assigned to the check then. So we calculate the overall severity level of an agent by accumulating actual STIG severity levels divided by the sum of the potential severities. Agents install systems that are target of audit, ZOS and many other legacy platforms. They report to the IronSphere server, which is a virtual appliance running as a KVM or VMware guest. User can access the server using a browser. We currently have ZOS agent supporting RACF and Top Secret, and soon we will support ACF2. It will be shipped at the end of 2018. After development, under development are the Linux and the IBM I agents. We plan to supply product packs to support and assess more third-party products other than those that already supported by the standard STIG packages. These packages will be downloadable from our website for paying clients. The idea is to have a focal point of all legacy or third-party products, and in short future, also COBOL applications. IronSphere allows the definition of 3 types of user roles: administrator, which can see and configure the server; a security officer that can watch all findings; and a configurable role called guest. Guest users may have assigned specific STIG groups according to the role in the organization. For example, a DBA may see DB2 and IMS STIGs, assuming that you have these databases. The CACS guys will see CACS-related issues only. The MQ team will see MQ issues, etc. Once you see the so-called system view, the user can narrow the view by severity or a STIG group or both of them. The view and the collection is limited to his assigned STIG group, so in matter of fact, to his role. The user can then export all or selected items from the list to PDF or XML in order to communicate with other systems. You can import the XML, maybe needed some modification to the structure, but it's possible. Watch the history of a specific check and even compare a check with the same check on different monitored systems from the same type of operating system. Another view is the point-in-time history compliance report. This is important for the European GDPR Act and might be required by US local act as well. Last thing here are the graphs, which helps identifying major risk sources and understand your security issues. It also shows big picture of your system. So this is a typical main dashboard called Systems View in IronSphere terms. We will now switch to the demo. This is the IronSphere logon screen. You have to specify user ID and password, and they will be checked against the Active Directory of your organization. But this is not, it's a prerequisite, but it's not enough because you have to have a role in the system. Otherwise, you won't be able to log on and you won't be able to view any of the findings in the system. So when you specify user ID and password and click login, the system will show the main view. You may remember that there are some other main views displayed in the presentation, which has more operating system groups displayed. In this demo system, we have only ZOS in the main view. The gauge shows highest risk level measured for one of the agents from this family. So if we click here, we can see that we have 2 agents running on MVS-A and MVS-B with different security severity levels. 66 is the highest one, so it's ordered from left to right, and this is one that will show in the main view. If we click on one of the systems here, we will go to the system view, which is the detailed report of the system. It has several parts, which we will discuss now. First of all is the title bar, and you can sort each column by clicking on the title of the column. It will be sorted in 2 directions. The first one will change from ascending to descending, and the second one back. And you have some information about the system. It says it's MV, stands for MVS, R for RACF, and the rest is based on the family of the STIG, and the reference here is the STIG name from the STIG document itself. This is a time where the check was last run, so the report shows only the last runs of the reports. of each of the checks. So it's up to date. If you run your system in a good way, as the agent should operate, you will see up to date security status of your system. Once displayed, you can drill down into the details of the report. So, for example, if I click on this line, as you can see, we can see the entire report, but within the entire report, we can see the specific check details. So this is the subject, or the title came from the STIG document itself, but it's not enough, because most people which are not mainframe users, we want to understand what is sys1 LPA lib, etc. So there's a description here, again, came from the STIG document, which explains what it's all about, why it's risk, the classification of the risk, in this case, data integrity, the operating system name and version of the agent, where the agent is running, who is responsible for fixing the finding, and this is how to fix the finding. And what the agent does, it sends you a result table, which says which, in this case, for example, it's sys1 LPA lib, so it will discuss sys1 LPA lib configuration in RACF, in this case, because it's a RACF system. So it says the dataset is sys1 LPA lib. It is protected by sys1 .*, which is the profile. The field in concern is audit. It currently states failures only if you are trying to control the dataset, for example, deleting that. But the requirement from the STIG is to have update, and updates are not including. So what I'm trying to say here, we are saying not only what the error is, what the value of the control, but also what is needed to be set. You can see that there are users which are not allowed because they're not part of the system group, or the groups which you specify in the configuration of the product that are part of the system group, or those that are allowed by the STIG to use the product, the data set in this case. You can select a line and see the history of the check. In this case, you have to specify the window. I know that it's quite old data, so I'll start at the beginning of the year until more or less, let's say, 28. And we get a history of this check. You can see that it all high, so nobody takes care of that. And the history, when the dates of run, of course, you can sort it from the last run to the first one. You can then click on it, export to PDF or CSV, and if the person which is responsible for this check is not allowed to access the system, he can be aware of the risk if you just export it to PDF and send him or his manager or any other person that you want to be aware of the risk. Another thing that we have, another functionality, is to compare the risk within the other agents of this family. So if we click compare and we still kicked the line, you can see that we have two systems here, MVSA, MVSB, which are the audited systems of the ZOS family, on different dates, but on different severity. So this issue is not present on SysB, it's fixed. Again, we will reset the page. So we know the scope of the handling of the error. We can have a point-in-time report. This report reports what happens now in your system, but you can have a report referencing a date in the past, because if you need to show your compliance report specific date in the past, you can do that by specifying the date. Just click on point in time. You can filter results. Remember that the idea here is that everyone is responsible for his own risk. It's like you just have to maintain the list and maintain the users who are authorized to view the reports and part of the reports, but each person is responsible for his own finding and need to fix them, because you can't fix them yourself. You're a security officer, not a technician, nor a system programmer or DBA. So we can export that and can show them that, but they can see here in the list only and only what you are allowed them to see. So if I'm a DBA, I will only see DB2 here, or if I'm a RACF officer, I will see RACF. Communication guys will see all the communication families of STIG. We can also select on severity, filters the results by severity. In this case, that's what I asked for. So you can see we see only high severity findings. Another option here is to view some charts which shows you the big picture. The report shows the details which are specific to a system and specific for STIG family and specific for a check, a single check. Here we can see findings which are more information about the entire monitored system. We're still on sys MVSA, but we can see, for example, the distribution of checks which marked as with severity high, and we can see where our problems come from. And you can see that ACP, the operating system itself, the lists like APF, linked list, LPA, etc., are those that are more risky in our system. So it's a system programmer duty to fix them. 18% come from RACF, and the rest comes from SSH, if I'm not mistaken. Of course, you can select whatever you like. To see that 75 here come from RACF and only 25 come from AMV, etc. So you can have more visibility about your system, where it comes from, who is responsible, who makes most of your problems. Now you can dig into a specific analysis, for example, the data analysis, AMV, and you can see that 15 checks are marked none, so it's relatively good because these are the most of the checks. Only 1 is low and 3 in medium, and you don't have high severity findings. If you're administrator, you can see some of the administration options here. You can connect the system to Active Directory, which probably that's what you would do. You can see the activity log, define users and their roles. You can define your own customer data, like your copyright statement, phone number, address, name, the data format, a logo if you have one, and number of days to alarm an inactivity of a check. If you see here, it's 250. If I change it to 150 and click submit and go back, if I look at, for example, MVSA, it will mark everything, every line which is not in the it's outside of the window of the last 150 days, to show you that those checks haven't run since that time. And you can see that the entire line is colored red, except the severity, to maintain the severity levels, the regional severity levels, so you know where you are. In this case, you're able to send this report to the system programmer, which is responsible for your product, and say, hey, something is wrong with IronSphere because my baseline interval is 12 hours and a day passed and those checks haven't run since, so we have a problem. Another, let me change that again because it's, I want to show more information about that. So another option is to have an idea what is happening in your system, how healthy is IronSphere agent. You can click here. There is a mailbox which tells you what is happening. For example, if the check is not able to perform well on the mainframe, for example, because the user which runs the check is not authorized to verify the resource. He's not authorized to query RACF. He's not authorized to list the control file, family, whatsoever it is, Unix system services configuration file. You'll get a message, the user ID, the command in question, or what he was trying to do, and how to fix the problem. So you can send it to the person, for in this case, the system programmer, who is responsible for managing system products and security products as well, because he's the one who installed them. If he fixes the problem, you can remove the message. So as you can see, IronSphere is very simple. It aims someone which is not mainframe expert. He doesn't have any understanding of the mainframe, but he knows that in a scale of low to high, the problem is marked high, so it's really high. The severity is high. He knows what the problem is about and how to solve it and who should solve it. So he doesn't have to be a mainframer, but he knows what it is, how to fix it, who is responsible for that, and at the bottom line, a better possibility that the problem will be fixed and your system security level will be well and will be in compliance. So thank you, and we will answer questions now if you have.
Thank you, Stu and Itzhak. And I want to thank everyone for hanging in with us today during the sound disruption. We're going to provide a link to the webinar for you, and we will make sure the sound is on that link. And it was about a half an hour in. If you want to look for it when you get it, look for that section that you missed. I have a question that I think may be for Stu. The question is, are we seeing an improvement in auditors' knowledge of the mainframe so they can dig deeper and know what to look for?
This is Stu, Yvonne. It's a good question, and I think the answer is sort of sad. A part of this is, I think since maybe 2008, travel budgets and training budgets for IT staff as well as for auditors have been cut just when the economy got tight. But my impression, it's highly biased, but my impression is that auditors are not improving their knowledge compared to what they were 5 or 10 years ago.
Okay, thank you. And this one is probably for Itzhak. It's a question about mainframers. It says, you said mainframe experience is not needed, but is a bonus. I am an experienced mainframer, so what is the bonus?
Well, if you have several systems, assuming that you have test, development, system test, integration, production, and maybe a fixed frozen version of the production, so you have already 5 or 6 LPARs. If you're running Sysplex, it's double the number. If you have some GDPR, for example, GDPS, sorry, regions, so you go even farther. And I know some clients that run about 100 LPARs. So it's not easy to do the assessment LPAR by LPAR. And the idea behind IronSphere is that it does the assessments for you, and you only need to look at the results. You don't have to run the jobs. You don't have to log on to TSO, generate the reports, view them. It just run automatically. So you save your time, and you can concentrate in solving the problems instead of collecting the information about what problems we have.
Okay.
Itzhak, this is Stu. Yvonne, if I might, I'd like to add to that a little bit.
Yes, please.
I guess just to give an example, if you think about an APF authorized library, if you're a systems programmer with some experience, you understand anyone who can write to an APF authorized data set can bypass all the security on the system. So if, for example, you have an APF authorized data set, and someone has put a rule in RACF, ACF2, or Top Secret that says every user can write to this APF authorized data set,
and it doesn't get logged, so management wouldn't be aware that it had happened. If you're just an auditor who's been told APF is something important, so go look at the list, and if it says high, then write something in the audit report or pursue it further, that's one level of knowledge. But if you've got the kind of background knowledge that the questioner seems to have, you'd look at that and you'd say, my God, that's my APF authorized data set. I know what that means. I'm not going to allow that to happen in my system because I understand the risk. And that's really what the bonus is. Your knowledge will be informed and passionate.
Thank you, Stu. I have an IronSphere question. The question is, can you modify the description of the risks in the IronSphere product? Itzhak?
I'm wondering if Itzhak is on mute. This is Stu again. I'd like
Hi.
to jump in a little bit on that. I believe
Yeah.
the product does. Itzhak, you're there. I'll let you answer.
Yeah, okay. So the STIGs themselves are shipped and displayed as they shipped from the DoD. So you don't modify them, but we will soon differentiate between those that are classified and those which are not. So, and some people asked us, for example, for the password policy, which they don't have the same password policy as classified clients, federal clients. So we consider passing parameters to the check itself, specifying your own password policy. But it's rare because the idea behind the standard is to enforce the standard. And we don't want to change the text or the verification of the settings of the control, security controls. So
Okay.
I hope this makes sense.
Okay. Let's see. I'm looking here. Do you have a link you can share that provides more details on IronSphere system requirements for deployment and architecture? I guess
Yeah, well,
that's
it's very easy.
installation question there, I guess.
Yeah. Well, it's very easy. It's only requires supported version of OS. So it's for ZOS, it's 2.2 and 2.3 because 2.1 is going out of service soon. There are some PDFs that you have to install because we use intensively JSON and TCP/IP. But there is no specific requirements out of that because we use standard ZOS interfaces.
Oh, okay. Thank you. We are right smack up against the hour right now. So I just want to thank Stu and from Henderson Group and Itzhak Mitzhak from SecuriTeam for being with us today. And again, we're going to provide you information from this webcast. So someone will be sending you an email. And we want to thank you all for joining us. Hope you found something new or thought-provoking to take away. If you have any questions or would like to talk to someone at SDS about IronSphere, you can send us an email to info@stsusa.com, or you can call us at 1-800-443-6183. Thank you again. Oh, and if we didn't get to your question, we will answer all questions. But thank you again for joining us today, and this concludes our presentation.
Thanks, everybody.